Good morning, Year 10. In this video, I'm going to actually finish the log part of the topic in this lesson today, which might feel weird because we've only spent 3 lessons on it, and that's because there isn't much content to learn. There's more depth when it comes to this topic. So what will happen over time is in the 5 questions, we're actually going to look at this in a bit more depth, as I say, just so we can get a bit better at it. So what we're going to do today is bring together a lot of the things that we've already been looking at. But realistically, you may find that you actually already know how to do this, and that is because you know how to BAP from the first lesson. So generally speaking, when you're solving any exponential and logarithmic equations, so remember exponential is anything with a power and logarithmic is anything with a log in it. So whenever you're solving either of those equations, when you get stuck, you need to BAP it. Hashtag lunch is ready. So for our first example, you'll see that we talked about this in the first lesson, we don't know what that x value is. So because we're stuck, we're going to BAP it. So first thing, I'm going to label everything. So I've got my base, my power, and my answer. And we remember that for BAPing, we're going to have log BAP. That's our BAP. So that's what we want to have here. So I'm going to have log, and the base is 3. The answer, so the A, 243, and that's equal to the power, which is x. And the reason why this always works is because the only times you will get stuck is actually when you will need to do the BAP. If you're not stuck, you won't have to do it. So now that I have changed its form, I'm going to do the change of base, so I can type it into the calculator and I'll be able to find what my x value is. So I'm going to do log, and remember base 10 is how we can get it into the calculator. So that's 243 over log base 10, 3. So the number on top goes on top and the number on the bottom goes on the bottom. And when I type that into the calculator, we're going to get log 243 over log 3 gives me the answer 5. So we're done. That's the answer for x. X is equal to 5. I might just write that at the end, which equals x. Now the next part B, involves a little bit more, but it's not that much more. The first thing that I'm going to do is I'm just going to put brackets around the m plus 1. So it's 4 to the power of m plus 1, which is equal to 1 over 8 times the square root of 2. So you can see we're bringing in some surds here, but it's fine, it all still works. So we're a little bit stuck, just like before, so I'm going to BAP it. So we've got the base, the power, and the answer. Going to rewrite it, so I'm going to have log base 4. The answer is 1 on 8 root 2, and that is equal to m plus 1. Okay, now we could do all the fancy little tricks that we were doing in the last lesson, where we can recognize that this is the reciprocal. And you know what, I will do that one, but you don't have to. You only have to do it if we're simplifying. So if we're solving, we don't have to do that. But it's good practice anyway. So I'm going to rewrite it as log base 4, 8 root 2, all to the power of negative 1. That's equal to m plus 1. So our next step would be to bring that negative 1 here. This negative 1 needs to come to the front. So I'll do that. So I'm going to have negative log base 4, 8 root 2 is equal to m plus 1. I'm just going to make some space for me, because we're going to run out of room otherwise. Now hopefully you're thinking, oh, can we just take away that 1 from both sides so we get m by itself? And yeah, totally. So I'm going to take away 1 from both sides. And I'm going to be left with negative log base 4, 8 root 2 minus 1 is equal to m. And that's our answer, but we can actually figure out what m is by typing this into our calculator. So I'm going to do the change of base, and that will give me my answer. The only thing you have to be careful of is that negative 1 will stay separate to the fraction. So I'm going to have log base 10, 8 root 2 over log base 10, 4 minus 1, and that should equal m. So I'll type that into the calculator now. So I've got negative log 8 root 2 over 4 minus 1, which is separate to the fraction, and that gives me a horrible number, negative 1.263 and so on, and we'll just leave it at that. That's the answer there. All right. So we'll keep going. Let's go to. Oh, sorry, I have made a mistake. When I typed in the calculator, I did log. I just did 4 on its own, not the log 4. Sorry, that should be negative 2.75. That's a lot nicer. That's good. We can sleep easy tonight now. So example 2. We're going to solve 5 to the power of x is equal to 17. Now, we don't know what x is, but that's okay. We can just, we can BAP it. So that's the first thing I'll do. So that's the base, the power, the answer. And so I've got log base 5, the a is 17, and the power is x. And I can't type that in the calculator, so I have to change the base to 10. Change the base, that's the whole point of it. I'm not going to keep it the same. And we can type that into the calculator. Now it asks for 3 decimal places, so we'll just write it, see like what it looks like first. So it's 1.76037, and to 3 decimal places we're going to do 1.76, and we'll still write 0. I know a lot of people might leave that out, but that's still considered a decimal place in this case, so we'll just leave it as that. Next, so example 3, we need to solve each logarithmic equation. I don't really like saying the word logarithmic, I just like to say log, it's a bit easier, but nevertheless it's in the question. Now part A, it says log base 5x is equal to negative 3. We don't know what x is, so we'll BAP it and see what we get. So we've got BAP because it's in the BAP form in the log. So that means we have the base of 5, the power of negative 3, and x is the answer. So there's a couple of ways we can go about this. If I were you, when I was in high school, I would type that into the calculator and get my answer. However, I think it's a bit nicer to actually know why an answer is an answer if possible, so I will show you. So x will equal, now the first thing I want you to see is that this is a negative power, so that means it's a reciprocal. So I can write that as 1 over 5 cubed, and 5 cubed is 125, so that is 1 over 125, and that is the value for x. Cool, let's do it for b as well. So we've got it in BAP form already, and we don't know what x is, and that's a bit hard for us to work with. So let's BAP it and see, and we'll get x to the power of 3 is equal to 18. Now, to get x by itself, we need to cube root both sides. So I'm just going to make a note of that. I am going to cube root both sides because that will get rid of the power of 3, or the cubic. So when I do that, I'm going to get x is equal to, and it's the cube root of 18. And now these they work similar to surds, but they're not the same as surds, so feel free to type it into the calculator and see what you get. So in this case, we get something that's not particularly nice, but I'm going to write it anyway. 2.6207 and so on. Okay, but if the question said in exact form, that is the answer that I would leave it at. But if it said to decimal places, there you go, you've got both options there. So just to quickly recap before I let the video end, we've got exponential and logarithmic equations. You work with your equations as best you can, but when you get stuck, you need to BAP it. Hashtag lunch is ready, of course. So in the first example, we did it from exponentials into logs. Change of base formula is our friend. We've done it once, twice, 3 times. So you can see how useful it is. Can't believe it's not in the textbook, hey? Example 3 is the reverse. So we have our log and we need to get it back into exponential form. That's with a power, so that we can find out what x is. And here's 2 versions. We've got one version where we can type it straight into the calculator, essentially, and this one where we have to do further steps, but at least it's workable now. All right, well, good luck with the work today, and I'll talk to you next week.